learn the core differences between a virtual machine and a container. Okay, like that, I'm going to put a small table kind of thing. Okay, so small table. Okay, let's say this is for container. Okay, and the second space is for the virtual machine. Okay, VM. So we are going to discuss with 3 or 4 important points, and going to see how it is going to behave. Okay, so there is a process called bootstrapping. So the first point is kernel bootstrap. So if you go to container, if you go to the container realm, in the container there is no bootstrapping process, because I think by this time we have seen many we have run so many containers so far to do testing and learning and all that. You may have known that. So container doesn't have a bootstrapping process because it does not have its own kernel. Only if it is having the kernel, then there is a bootstrapping process. It is not like a regular operating system or a virtual machine based operating system. So it doesn't have that capability. So I'm going to mark here as container does not have the kernel bootstrapping. So I just put it in the red color. No. But if you can check in the VM, you will be able to see it. Yes. Okay. Small checklist. And in the VM, I will show all these things by command how we can explain, understand all these things and justify the points. Okay, and then we can see sharing the kernel. When it comes to container always shares or consumes the host machine kernel. Container does not have its own capability to spin up a process or anything inside, because it is totally dependent on the host kernel. So sharing the kernel is true in container. So container shares the kernel of the host machine. Okay. And when it comes to the VM does not share it. So I just put it no here. Okay, because VM ships with its own kernel. You may have seen it because in the first Linux sessions itself, we have been dealing with the virtual machine. So I showed few commands and all that. So you know that it is true already. Okay. Now, in the third point, we have memory locking mechanism. So in an operating system or a virtual machine, okay, memory locking. Memory locking is a very common feature of any virtual machine. Okay, so if you go to any hypervisor like Vim or VirtualBox, or you have workstation VMware, anything. So if you try to spin up a VM, by default you need to. It will automatically take something, I don't know, but there is a process called memory locking. It's called as malloc process. Malloc, MALLOCK. It's a system call. Okay. So when a VM actually is created in a bare metal hypervisor or in a hosted hypervisor like VirtualBox, whatever it is, it locks the memory. Which means if you give 2 GB of RAM to the VM, the 2 GB is taken from the RAM. It cannot be used by any other VMs or the host machine. So that's the nature of VM. So in the VM, you can see memory locking is true. Okay, so I'm going to write it like true. So yes, yes. Okay. But in the container realm, it does not have a memory locking mechanism, but it has some other different mechanism called as a memory limiting mechanism. So directly speaking, it does not have a memory locking capability. Okay. So no in this part. And then we go to the next point, which is isolation. Okay. So isolation, uh, let's say isolation in terms of storage, isolation in the terms of CPU, isolation in the terms of RAM, let's say storage, isolation in the terms of, I think, storage, CPU, and memory. When it comes to container part specifically, we say container gives isolation. Okay, but that is just a level of abstracted isolation. I don't say it's a pure isolation. If you go to virtual machine infrastructures, let's say if you give 40 GB of space for a virtual machine storage space, it takes the 40 GB from the hard disk. It cannot release that. So it's a properly isolated space for that VM. But in terms of container does isolation, but that is not a pure isolation like a virtual machine. It's a kind of an abstraction based isolation. Maybe when I explain that thing in words, it may not be very easy to understand. But what I will do in the command is, I will show things in the command. Then you shall be able to understand what I am trying to explain here. Okay, so in the container there is no real isolation. Okay, it is just an abstracted isolation only. Okay, but in terms of VM, you get a pure isolation. There is a specific, if you allocate a specific CPU count, it takes that capacity. Memory, yes, it blocks the memory. So storage, 40 GB disk space means now you have ran the VM for a very long period of time, even the learning VM we have. So you know what I'm talking about now. Okay. So that's how it has a proper barrier. But in the terms of container, there is no proper barrier because it is an abstraction. It's an abstraction based barrier. Okay. So then we have the next thing, which is something called as cascading. Cascading failure. Cascading failure. Is a very important issue in terms of container infrastructure because containers are host dependent. It depends on the host resources. As I said, there is no real abstraction between, or pure abstraction, pure isolation between the host machine and the container. So, if the host is affected or if other containers are affected, you will see the rest of the other containers also get affected. That's a kind of a ripple that you can see. So in certain mission critical environments where I've ran 70, 80 containers per Linux box, I have seen that it is true. One container is affected, it affects the host machine and it affects the other containers in the host, hence pulling the host down in every way. You can't do an SSH. So the cascading effect, we can't simulate and see it in this session. Okay. But in the container, you see cascading happens if you have any malfunctioning within the workloads you are putting inside and all that. Okay. So cascading failure happens inside the container infrastructure very regularly if you don't find the proper culprit container. Okay, but in the VM infrastructure, you generally don't find the cascading effect. Actually, this is a positive point, but I'm writing it in the red color, so just try to adjust your view. Okay, so yes means green to show. Okay, so to identify. And then we have another point, which is called the boot performance. Boot performance. So the boot performance of containers are usually in seconds. Okay, it is usually in seconds. When it comes to boot performance, you can see containers were 100 times better because it is very, very lightweight. Okay, but when it comes to VM, we've been trying this Vagrant VM and all that. Even if you go to Amazon EC2 and all that, at least it takes in the cloud just another 10 to 20, sorry, 10 to 20 seconds to up an EC2 VM, EC2 server in the cloud. So this is I think these are all just the 6 points which clearly explains you the way how containers behave, the way how virtual machines behave. Okay. I do not know whether this is an interview question or not, but in my opinion, this can tilt your view on why we go for containers certain areas and why we go for VM in certain areas. Now, this is just a fair comparison. Now, my point not is to say VM is not the best thing and containers are the best thing. So, I am not here to come to a conclusion like that. If you ask me, uh, based on our use case, we provision containers and we provision VMs. Okay, so we don't use containers in every place in our product infrastructure anywhere. We don't blindly use VM on every places also. So we have a balance on what to use, where to use. If a technology can be used in a particular place, if it reaps benefits, we use that. If there is no benefit of that and it just brings an overhead, we don't use it because just other companies use it. So, so coming to the points. So the process kernel bootstrapping. Kernel bootstrapping. So coming one by one. So I'll write the reasoning for this. Kernel bootstrapping means it is a common process. Okay, so across operating system in the containers, this is the state. Sharing the kernel. Sharing means sharing the host machine kernel. Okay, sharing the host machine kernel. So I'm abbreviating. That is what I'm talking about. When it comes to memory locking, VMs do memory lock, but for containers, there is only memory limit. Containers only limit memory. It can't lock memory. Okay, memory means RAM, which I'm talking about. And then you have isolation. Isolation means it is an containers have an abstracted isolation. It is not an pure isolation. So you can't expect it to be 100% isolation like VM. So containers follow abstracted isolations. Follow or implement. Containers implement abstraction. Abstracted isolation. So cascading effect, it is something which you can see in the container infrastructures, but it is mostly not predominant in virtual machine infrastructure. Suppose if you go to Amazon EC2, Amazon EC2 is a best example of a VM infrastructure. Okay, and then if you go for Azure VM, it's a best example of virtual machine infrastructure where you don't see cascading happening. So these are all the examples of VM infrastructures. Okay, VM infrastructure in cloud. Okay, in cloud. VM infrastructure in cloud. So there you can't see cascading failure. Okay, so in these places it's a very fantastic example because you just imagine in the scale of AWS, Amazon EC2, Azure VM, and all that, there will be millions of VMs running for in a single tenant, and you see that if my VM is not performing well or something which I did wrong or my VM is overloaded, if that is going to affect the other customers' virtual machine, then their service, I mean, they don't get popular. I think cloud is a waste of time then. Okay, but you see, we are running the VM in the same tenant, another person is also running in the same tenant, but it does not cross conflict. Okay, so that's the best example that VM infrastructures there is no cascading failure. And the best examples for you to realize is the Amazon EC2 and the Azure VM, and even Google's GK is also the best example. Sorry, GC Computing G. And in terms of boot performance, containers boot performance is in seconds. Container boots in seconds. But VM sometimes take more seconds. Okay, container boots in, I think in my opinion, it is less than a second. So 0 to 1 second, mostly. But if you go to VM, it is not at that level of performance. So it takes time if it is EC2 or any infrastructure you see. So these are all basically the important facts about the container and the VM. Okay.